Let us understand the term subgroups with various examples. The name itself says subgroup is a part of the group. Subgroup is a smaller group. Yes, a group which is a part of the group, order of the subgroup G will be the divisor of order of the main group H. Means H upon G should be integer plus all essential conditions of the groups should be fulfilled. What were the essential conditions? First, closure. Second, identity. Third, associativity. And fourth, inverse. These essential conditions, if are fulfilled, an order of the subgroup G is a divider of the order of the main group H, then we can say that is a subgroup. Let us understand this by example. Say C2v point group. In C2v point group, total 4 operations are there. Means we say order of the C2v point group is 4. Which are the operations? Identity, C2 and 2 vertical planes. Say sigma xz and sigma yz. These are the 2 planes I am considering. Then following those 4 essential conditions, which subgroups can we establish? What will be their order? In general, 2 types of subgroups are possible. The first, trivial subgroup, and second, non-trivial subgroup. Trivial means mandatory identity operation alone will be there in that subgroup. That's a trivial. Other than identity, if we consider the operations, identity should be there because that's our essential condition. Then such subgroups will be non-trivial subgroup. As we consider identity is an operation for all, likewise identity in a set bracket, that's a which group? Yes, C1 group. That will be the subgroup for all groups. For C2b, first subgroup is C1 where alone identity is there. It fulfills all conditions. What is the first condition? Closure. E into E is equal to E. Second condition, identity. Identity exists there. Third condition, associativity. E into E into E. How many way? Whichever way you follow, you will get answer E. And last condition, inverse. Inverse of identity is identity. All conditions are fulfilled. Therefore, we say C1 is a subgroup of C2v, or it will be subgroup of any group. Second, special subgroup of C2v. We can collect identity and C2. These 2 operations. What is the name of that subgroup? Yes, C2. Their first condition, closure, E into C2 is equal to C2, the part of the group. Second condition, identity, yes, it is there. Third condition, associativity, E into C2 into C2, E into C2 into E. Any multiplication we do and that operation will be there in the subgroup. Fourth condition, inverse of identity. Identity inverse of C2 is C2. So all things are there. Therefore, I am saying C2 is a subgroup of C2v. Other possibility, I can consider identity and one of the plane, say sigma xz plane. That's a molecular plane. Or simply sigma also we represent. If identity and only plane is there, then what should be the label for that group? Yes, CS. So it is our third subgroup. And fourth subgroup, identity and other plane, that's a sigma yz or a sigma dash that we have not considered before. So total 4 subgroups are possible for C2v point group. Let us understand this concept by one more example. Say C3v point group. In C3v point group, total 6 operations are there. Therefore, we say H is equal to 6. Which operations are there? First, identity. Other 2 operations are C31 and C32. Next 3 operations are sigma, sigma dash and sigma double dash. Then which subgroups are possible for C3v? What is the first trivial subgroup? Yes, C1. So it is our first group. Second, identity. And if I consider only C31, suppose, will it form a group? Actually, total number of operations are 2. And this number 2 can divide the order of the main group 6. So it should be there by number point of view. But from condition point of view, first condition, closure. E into C31 we are getting, C31 into E we are getting. So closure is fulfilled. Second condition, identity is fulfilled. Third condition, associativity, that also can be fulfilled. But fourth condition, inverse. What is the inverse of identity? Identity. It is there. About that I have no question. But what is the inverse of C3-1? C3-2. It is not there in the subgroup which I considered. If I want to represent the proper subgroup with axis of rotations, then I need to consider three operations. Which are those? E, C3-1 and C3-2. G is equal to 3. And by number 3, we can divide number 6. So it can be subgroup and it fulfills all conditions. So it is our second subgroup. What label can we give for this subgroup? It is C3 subgroup. Remember the labeling of the point groups. Here vertical, horizontal, diagonal planes are not there. So only axis by which we are labeling. Which axis? C3 axis. So in general, Cn axis. Third subgroup, identity and one of the plane, say sigma. What is the label for that point group? CS. Yes. If along with basic trivial identity alone reflection operation remains, then that group or subgroup can be labeled as CS. As like I consider identity and sigma, likewise I can consider other pair identity and sigma dash. Point group is CS. Next, identity and sigma double dash. Point group is CS. Their total number of operations are 2. G is equal to 2. And by number 2 we can divide the number 6. So total 5 subgroups are there. Which are those? C1, C3 and 3 CS subgroups we are getting for C3 point group. Let us understand this concept for one more point group. Say D3h point group. In D3h point group, total we are with 12 operations. H is equal to 12. See the operations. Okay, which subgroups are possible for this D3h point group? First, C1 alone identity. G is equal to 1. It can divide number 12 and fulfills all 4 conditions. Second, C2 as a point group where I am considering identity and one of the C2 axis or C2 operation out of the 3 different possible C2 operations. So here 2 operation, G is equal to 2. By number 2 we can divide 12. So it is a subgroup. Such how many C2 subgroups we can get? Total 3. Previously one was there C1 and now 3. So 4 subgroups we have discussed. If I consider identity and horizontal plane, yes, these 2 operation possessing is a group and is a part of the main group. Order is 2. It can divide main order as a 12. Therefore it is a subgroup. And label for that is CS, where horizontal plane we can consider. Similarly, vertical plane possessing subgroups we can represent. How many vertical planes are there? 3. So further CS category of subgroups, 3 are possible. First was C1. Because of the C2, 3 C2, we got 3 C2 subgroups. Now CS, how many? 4 subgroups. So 1 plus 3 plus 4. How many subgroups total we have established so far? 8 subgroups we have established. Let us see whether further possible subgroups are there or not. Each subgroup is of the order 2. G is equal to 2. Now let us see little higher order subgroup. If I consider identity, C3-1, C3-2, total operations are 3. So G is equal to 3. Can we divide by number 3 to 12? Yes. So it can be subgroup. And all 4 essential conditions of the groups are fulfilled. So this is a subgroup. What will you label for that? C3 is a principal axis and only axis is present other than the identity. So label is in general Cn. So here C3 subgroup. It is a 9th subgroup. In C3v subgroup, identity, C3-1, C3-2, sigma dash, sigma double dash, 3 vertical planes will be there. If I consider collection of 6 operations, pay attention, which I am considering. Identity, C3-1, C3-2, sigma h, S3-1 and S3-5. For conditions of closure, inverse, associativity, all these operations are necessary. When alone axis we are considering, not necessary, but along with axis when we consider plane, then improper axis also is necessary. Roto-reflection operations also are necessary. So here how many operations are there? 6. Can we divide by number 6 to 12? Yes. So it is a subgroup of order 6. What can be labeled for this subgroup? Principal axis is C3. Which kind of plane is present? Horizontal. So Label for this subgroup is C3h. It is our 11th subgroup. Now let us consider last possible subgroups where again 6 operations are there, but all are access other than identity. First identity, which rotation operations are possible? C3v, C3v, C2 for one of the C2 axis, C2 for other C2 axis, C2 for third C2 axis. So I can say C2 dash, C2 double dash, C2 triple dash. So total operations are identity, C3v, C3v, C2 dash, C2 double dash, C2 triple dash. 6 operations are there. What will be the label for this point group? Principal axis is C3. Order of the principal axis is equal to number of subsidiary axes or subsidiary operations. So what to do? Capital C or capital D? Capital D followed by the order of the principal axis. So D3. There is no any kind of plane we are considering here, horizontal, vertical or diagonal. Only D3 will be the representation. So it is our 12th subgroup. If I have to sum up for D3h point group, we are getting 12 subgroups. C1, that's a trivial subgroup. 3 C2 category subgroups. 4 CS subgroups. 1 C3 subgroup.
1 C3h subgroup.
1 C3v subgroup. 1 D3 subgroup. So total 12 subgroups for D3h point groups.
Here possible 5 subgroups for C3v point group are represented. Order of the main group is 6. Then what can be the order of subgroup? It can be 1, it can be 2, it can be 3. All possibilities we are discussing. First subgroup is C1 where only one operation identity. Second subgroup is C3 where 3 operations identity, C31 and C32. Third subgroup is CS where identity and one of the vertical plane, say sigma V. Fourth subgroup is C-S. Operations possible are E sigma dash V. And fifth subgroup C double dash S. Operations possible are E sigma double dash V. In true sense, for point group dash double dash likewise representations doesn't remain, but it's only for our understanding purpose. In order to distinguish different CS point groups, the prime and double prime is used. 12 possible subgroups for D3H point groups are represented here. If 12 is a number, then subgroups can be with the order 1, 2, 3, 4, 6. But there is no any subgroup which has the order 4. But other possibilities are considered here. At the beginning, C1 where H is equal to 1 or G is equal to 1 is represented. Then subgroups of order 2. Total we are finding 7 subgroups of order 2. Cn category where C2 axes are playing role, and 4 Cx category where vertical and horizontal planes are playing the role. There is one subgroup of order 3 labeled C3. 3 subgroups are there of order 6. One is C3h, other is C3v, and last one is D3. As a homework question to you, already I discussed the subgroups for C2v point group. Only you have to mention in the comment box those 4 subgroups for C2v point group.
So students, is the concept of the subgroup clear to you? We have discussed in detail C2v, C3v and D3h point groups. It will be the more clear when we will know the multiplication table, because associativity, closure, unless you know multiplication, you will not understand that. So in next part, we are going to discuss multiplication tables for few point groups.